of meaningfulness of the operation suggested by R3. It's easy, the job. We perform the experiment on my system. We use the threshold to cut all the operation suggested by R3 with an high confidence level. Okay? So in this way we analyze only the refactoring operation that for R3 are really important. We discarded the operation with the low confidence level. The confidence level is also a way to rank the refactoring operation suggested by the tool. The higher the confidence level, the higher is the priority, in other words, to the refactoring operation that you have to perform. We decrease the coupling, we improve cohesion, so the sanity check is okay. We involve 48 external developers. This time we were able to involve not only students, not only master students, but also PhD students, and some people from the industry, so also some practitioners. They classify the meaningful of the suggestion in the high confidence scenario as meaningful in 75% of the cases, so almost all the cases were considered, almost all the operations were considered meaningful, and half of the explanation for why you should move a class from one package to another were considered meaningful. So, refactoring operations were considered meaningful, and by 55% of subjects, also the explanation were considered meaningful. We have clearly a super paper now. We submit the paper to AC, Automated Software Engineering Conference, and the paper was rejected. The second evaluation does not seem realistic. The developer subjects of the evolution have no experience in the software system, as you said before. How can they be expected to provide accurate responses on how the system should be modularized? The developers that we involved are all external developers. So they do not have enough knowledge on the system to evaluate a refactoring operation. Always the same problem. When you work with subjects, your life is really hard. You cannot involve students because your paper will be rejected. You cannot involve external developers. If they are practitioners, but they are external developers, your paper will be rejected. So the perfect scenario is to involve the developers that actually build the system. And the problem is that the evaluation with the external developers are not bulletproof. So what we did, we sent an email to the original developers and asked exactly the same question. So we redo this experiment with the original developers of 4 systems. So we identify from the mailing list the name of the original developers, and we provide the survey to these people. What we obtained, that the meaningful suggestion of the refactoring operation is higher as compared to the percentage of developers that considered meaningful the refactoring operation is higher as compared to the first experiment. And more important, and you can see here the experience play an important role, the internal developers that have knowledge on the system considered the 70% of the explanation of the refactoring operation meaningful. Bingo! We have a paper, but we need both original and external developers, because if you look at the result that we obtained with the internal developer are better than the result that we obtained with the external developers. But still, we probably need both category of developers, because the original developer can give you a deep knowledge of the system and are particularly useful when you have to perform qualitative analysis, because they can give you meaningful rationale about their score. They can justify something that happen in their system. They can give you rationale behind all design decisions, but original developers have a problem. Especially if you are evaluating a refactoring approach that remove problems in the code, developers could be the author of bad design choices. This is my choice. Is good by definition. Okay? So we need external developers, even if they can provide good knowledge of the system. They cannot provide rationale behind design decision. They can provide an objective evaluation of refactoring. The first lesson in the software testing course is that the test of a system should be done by people that did not participate to the development of the system. So also, if you want to evaluate a refactoring operation, you probably need something that is external from the development team. But the evaluation is still incomplete. The evaluation of all this approach is still incomplete. Because we can say that the proposed approach improves software quality in terms of cohesion and coupling, of course. We can say that the proposed approach are able to suggest meaningful refactoring operations, of course, but this question is still open. Is the proposed approach really useful during software development activities? If you want to evaluate the usefulness of a tool during software development activities, you need to perform a different study, not a survey. And I will show you what we did with a tool that we call Muse, Method Usage Example. In this paper, we present a tool that provides you code example. The tool works in this way. Analyze method API calls, extract the slice of the method API calls in order to see which are the steps that you have to perform in order to call the specific method of the API. Then, after collecting these usage example from open source system, the tool group together similar examples, select just one representative example for each cluster, automatically comment the example and provide to the developer the usage example, the complete usage example. You can find more detail on the approach in the paper if you want, but this is just an example of example generated by Muse. Here you can see this is the copy input stream to file, this is the method of the API, and this is an example on how to use this method. The question is Muse useful? Well, the question can be easily answered if we ask developers. And specifically, this is the design of the study that we conducted in order to evaluate Muse. Our research question, are usage examples extracted by Muse considered useful by developers? So, first of all, we analyze the usefulness of code example extracted by Muse. In order to perform this experiment, we send a survey to developers from open source and we send a survey to open source developers and professional developers asking if the example generated by Muse are useful or not. So we analyze the perceived usefulness of the example we generated with Muse, and we involved open source and professional developers. In order to do an experiment like this, you need a set of usage examples provided by Muse. So you need to apply your approach in order to extract a set of usage examples, but this is simple because there are a lot of libraries that you can find on the web. You can find also the source code, so you can run your tool on these libraries and extract usage examples. Then you need a group of open source and professional developers as subjects. These are the systems that we considered look, we consider two generic, widely adopted libraries from the Apache community, and 4 libraries that serve to more specific tasks. So 2 systems are more generic, and 4 are more specific. We ran Muse on these systems, and we extracted the 10 best usage examples provided by Muse. Where best, I mean the usage example classified as the best by Muse, because Muse is also identified the quality of usage example. At the end, we obtained 60 code usage examples extracted from 6 open source software projects. As for the subjects, we invited library developers. So we invited developers that participated in the development of the libraries, and probably developers that participated in the development of the method for which Muse provides usage example. So the original developer. And also we invited the client developers. Developers that have used in their project the library object of our study. So we have 2 different perspectives. The usefulness evaluated by the developers, the original developers of the method, and the evaluation of the usefulness of the usage example of the people that have used the method in their project. We invited 100 library developers and more than 600 client developers, mining the mailing list, list of contributors who were able to find their email. Of course, we sent them a survey. A survey that is organized in 2 parts. The first part, and this is a part that every survey should have, is you ask questions related to the background of the subject. So in this case, we collect data about the experience and the industrial experience, how often do you make use of third-party libraries in your software project, and so on, in order to know the people of your population. The second part, instead, is the evaluation of the example. And specifically, we show to the participant the method in terms of code. This is the code of the method, and this is the usage example provided by Muse. So we provided the code of the method and usage example, and we asked the question, how useful is the code example in understanding the usage of the method under analysis? So people evaluate the usefulness looking at the code of the method and usage example. Of course, based on the famous reviewer of the MC paper, we also asked people why you are giving this score to, why you are answering in that way to our question. This is very important, especially when you involve practitioners and send survey to practitioners, give them the possibility to complete the survey in steps. Okay? Because, okay, you can say, look, for completing my survey, you need 1 hour. 1 hour is an acceptable amount of time, but for you, not for practitioner. An acceptable amount of time for a practitioner is 3 minutes, 4 minutes, 5 minutes. So give the possibility to practitioner to spend 1 week to complete your survey, even if your survey just takes 1 hour. Okay? It is completely useless to give 3 months to people to answer to your survey. It's like the review, similar to the review period. If people want to participate to your survey, they start completing the survey just when they receive the email. Okay, so 10 days, 2 weeks is a good time that you can give to practitioners to respond. At the end, we collected 119 complete questionnaire. remember that we invited 100 people from libraries and 600 developers from professional developers. So 700. This is the acceptance rate. Is around 70%. Is enough? Well, for some people, no. And this could be another reason for rejecting your paper. But if you look at the state of the art, this is a very, very good number. Because in general, the response rate is between 10 and 15. Okay, so we are higher than 15, we are 17. Also, if you look at the number instead of looking at the percentage, we have more than 100 people that answer our question. So probably this is a good number for a population. Lionel Briand did not agree with this statement. He said that there was a post on Facebook saying that all the results based on questionnaire with such a response rate are completely useless. So if your reviewer is Lionel Briand, you are in trouble. You can if you submit the paper to X, you can declare a conflict, so you can avoid to have Lionel Briand as a reviewer. Okay, which are the results of news? This is the background of the developer, and we summarize the background with box plot and tables, just to show an idea of the population. As for the usefulness of code example, we report the answer once again through box plot, one for each system. It's important in order also to evaluate the effect of the system, because could be, remember that we have two different categories of system, two well-known and generic libraries, two more specific, and four more specific. But we also analyze the result globally. Important are the comments that the developers leave in completing our survey. Well, if you read the comments, it's nice to see when people say, oh, nice tool, I want to use it, but more important are the negative comments, because are the explanation very often on why people don't like your tool, or don't like your method, or don't think that your method is useful. These are the results, okay? So we obtain a good result, and these are the comments left when participant did not provide a positive answer to our question related to the usefulness. And specifically, we use these comments in the paper, and it's really nice to see in the paper examples of comments, because you can explain the why people don't like the example. People don't believe that the example is useful. And one of the reasons is unnecessary complexity. The example was too complexity in order to explain the method, or there is a person that completed the survey that said that it would be fantastic to also report the output of the API invocation when possible. So he said that in order to improve the usefulness of the example, it's necessary also to describe the return value. But still, is Muse useful? Because with this first evaluation, we analyze the usefulness of code example generated by Muse. But the approach is useful. In order to perform in order to answer such a question, we need to perform a controlled experiment. What is a controlled experiment? It's an experiment that you conduct in a controlled setting, in a lab, in a room, where you invite people to participate, and you provide people to your tool. So we are here, and we are performing a programming task. And I give you muse. This is muse. Please use muse during this programming task. And I can observe how this treatment, use of muse, can influence your performances. Okay? This is the experiment scoping of our controlled experiment. Look, using muse, that is the cause construction, we are able to improve the productivity of software programmers. For the first time, I'm talking about productivity. So, for the first time, I'm evaluating a tool on the field during programming tasks. The scoping of the experiment is the same, similar to the previous one. The object is muse. The purpose is how useful are muse code examples to the variable during a programming task. The quality focus, what I'm measuring. How can I measure the productivity of software development? Measuring the completeness of the task I assign to them. So, I assign a task to Simone, I say to Simone use muse, and then I can analyze the completeness of the task. This means that Simone had to perform the task in a limited amount of time, because if I give to Simone 5 months to complete the task, probably Simone will be able to complete the task. But if I give to Simone 1 hour to complete the task, probably Simone is able to only complete a part of the task. So this means that I can measure in a limited amount of time which is the completeness of the task performed by the people involved in the experiment. The context is represented by a group of industrial developers. We were able to invite in this experiment industrial developers, and a set of development tasks requiring API of specific libraries. This is the planning when you have subjects and when you have controlled experiments. The planning is more complex, especially because you have to select the experiment design. Okay? So when you have subjects, the complexity of your experiment increases, of course. These are the definition of the task that the developers had to perform in a limited amount of time. I will not give a detail on the task, but I just reported the description in order to give you an idea that are not toys example, but are quite difficult tasks to complete. And also, the tasks are divided in subtasks, where each subtask requires a specific library. So we are asking the developers to perform a task with a specific library. We need this constraint because we are providing to the developers an example on how to use a specific library. So if the developers does not use the library, we cannot evaluate the benefits of use. Why 2 tasks? We understand this in a couple of slides. When you have a controlled experiment, and in general, you can also define an hypothesis. And you can use statistical tests to verify your hypothesis, and specifically to reject the null hypothesis. Max this morning said the p-value, talk about p-value. P-value is the number that you have to look when you apply a statistical test in order to understand if you can reject a null hypothesis. A null hypothesis, in case of muse, is something like that. My idea, the cause-effect relationship is that if I use muse, I increase the productivity of developers. So the null hypothesis is exactly the contrary. There is no difference between the productivity of programmer using muse and programmer that do not use muse. So with null hypothesis, I'm saying that muse does not provide any effect on the development. My goal is to collect the data and apply statistical tests in order to reject the null hypothesis. If I reject the null hypothesis, I can admit a positive effect of muse on the dependent variable that in my case is productivity. Which are the independent and the dependent variable of our study? First of all, independent variable, code example available? Yes or no? This means that in our lab, the subjects can do the experiment with the code example provided by Muse or without code example provided by Muse. This means that in our lab, developers can do a task as they usually do, surfing on internet, using their preferred ID, we don't care about this, but we also give to some subjects the documentation of the API enriched with the code example provided by Muse. The dependent variable is the completeness of the task. As I said, developers have a limited amount of time to complete the task, that in our case is 1 hour. And you see that the tasks are not so easy, so it's very difficult to complete the task in 1 hour. But the problem is how to measure the completeness. The easiest way is to perform a Boolean evaluation, complete, not complete. But as said before, the completeness is strongly related to the amount of time that you give to the developers. Based on the difficulties of the task, if you give people 1 hour, probably they are not able to complete the task. So this means that if you apply a Boolean evaluation, all the people will have a score 0. On the other hand, if you give people half day or 10 hours to complete the task, probably almost all the developers will complete the task. So we'll have an evaluation rate equal to 1 for each participant.